All right, hello, welcome back. What I want to do is to continue to look at differentiation. Now, you will recall that I did a bit on integration earlier in regards to one or two of the videos. Now, remember that to be effective in this, you need to be writing this up for yourselves. You need to be extracting information. You need to be making it your own. Okay? There's no shortcuts. There's no quick fix. Okay? Now, hopefully, if you apply the knowledge you have acquired from the screen and you have extracted the information, do some additional research for yourselves. Now, I use a book by A. Gray and G.W. Taylor, Mathematics for Technicians. And I don't know whether or not this is still in print, but it's useful because you can take it with you and it's not bulky to carry in your briefcase or in your bag. Okay? But it gives you quite some useful information and insights. Okay, thank you. Now, so what I want to do now is to bring in differentiation. And excuse me for a moment while I get the camera. Okay. Now here, Mathematics for Technician Level 3 differentiation. Now, the process of differentiation is a method of finding the rate of change of a function. Okay. Now, the rate of change at a point on a curve may be found by determining the gradient of the tangent at that point. Sorry about that. Okay. Now, this may be achieved by either a theoretical or graphical method as follows. What that means is that we can do it by mathematical calculations or by a graphical method using a graph. Suppose we wish to find the gradient of the curve y equals x squared at the point where x equals 3 and x equals minus 2. From a theoretical approach, you may remember that if the function is of the form y equals x to the n, x to the n, then the process of differentiating gives dy over dx equals nx n to the minus 1. Hence, if y equals x squared, then dy over dx equals 2 to the x, or 2x. Okay? Now let me just pan off for you so you can get it all in, okay? Okay. All right, let's turn over the page, and let's hope we can turn the page over without a lot of faffle. Oh yes, okay. Now differentiation, and therefore when x equals 3, now remember we're continuing from page 1, okay? So all I've done is simply continued, okay? So look back at page 1 if you need to, or go back in regards to the video yourselves. The gradient of the tangent is dy over dx equals 2. Now 2 times 3 is 6. Okay, and I've simply write it out. Now again, remember it's purely how I work. Okay, you would just say dy over dx equals 6 in some cases. Okay, but I like to see where it's coming from and how I have arrived at that solution for future reference. And when x equals minus 2, the gradient of the tangent dy over dx equals 2 times minus 2 equals minus 4. Okay, now Now, alternatively, if we decide to use the graphical method, we must first draw the graph as shown in figure 1.1. Okay. Now again, I produce a table. Sorry about that. Okay, now I've produced a table. This is the graph for figure 1.1. We must produce the table first of y equals x squared. Okay, and this is what I've done here. Okay. Now let's turn over. Okay. Now I've got to turn this around, so bear with me, okay? Now you would recall that we were talking about the tangent. But the tangent is this line that intersects that graph at that point. It intersects it there, okay? And it also intersects it on this side here as well, okay? That's your tangent line, okay? Now let me just go back a bit so you can get it fully in, okay? Go back further still, sorry. Now go back a bit more, okay? You can get it fully in, okay? So you can see. Now you then notice that we've gone on to talk about 2 over 10 equals minus 5, okay? And taking the information from the graph, you plot this graph, and this will give you this shape, okay? And this is the graphical representation in regard to figure 1.1, okay? Now 10, because that's 4, 8, and that's 2 is 10, and that's 2, 4, okay? Now where x equals 3, the gradient equals am over bm equals 12 over 2.2 equals 6. Now, I've written here am over bm, but please note I'm looking at this from this side, okay, am over bm, okay? That's where I am at. It's just that, again, please note, it's just the way I work, purely how I work, okay? Now, and where x equals minus 2, the gradient equals Pn over Qn equals 8 over 2. I think that should be 10 over 2 actually, but I must have put 8 for a reason. Okay. Because I do have 10 here, right? So obviously, but I'm going to go ahead because I would have done that for a reason. Just that illustrating it at this point in time does not seem to remembering the reason as to why. But that's the process you will need to apply anyway. Okay. So again, remember that. Okay, because that should be okay. Yeah. And I'm just checking my y values that they are constant both for positive and negative. Okay. Okay. So we can see here that the gradient in this case is 6, and the gradient in this case here is -5. Okay. And -5. Okay, let me go back to that now. Okay, bring it in. Okay. Okay. And bear with me for a moment while I go to the next page. Because what I did here was to create a graph, a table, I should say. I produced a graph already, which we just looked at, figure 1.1. And this is the table that I produced to give me my graph. Okay. We now want to draw the graph for y equals 3x squared plus 10x minus 8. So we need to produce a table. And I produced this table here in regards to this. Okay. Now, remember, you will need to produce your own table for yourselves in order to understand the concept and how it has been calculated out. Okay, and do it for yourselves. And it should work out correct. Okay. We now have our table. Okay. We now need to plot the graph for y equals 6 squared plus 10x minus 8 for values between x minus 6 and x to the 4. Okay, let me just take this out a bit so we can get it panning fully. Okay. Okay. And again, remember we're looking at differentiation. Okay. Okay. Now, having plotted the table, okay, I then need to apply it to the graph. And you can sense it. Now, let me just go out a little bit so you can get this fully in line. Okay. Okay, y equals 3x squared plus 10x minus 8. Okay. Now again, always produce a table. You need to produce a table so you can plot the graph in respect of x. And here you have minus 6 equals 40, okay? When x is minus 6, y is 40. That's what it's saying to you, okay? When x is 4, y is 80, okay? And that is your tangent intersecting your graph. Again, that's your tangent at intersection. That's what you would refer to as your gradient. Okay. Now, you'll notice here that this table, the minus in regards to the y-axis, did not go below minus 40, simply because there was no need to it. There was no values at that stage. But we did have values for the tangent in each case. Okay. Let me just make sure I can get it all in. Okay. You can see. And let me just move into each case. This one, okay, here. You can see the intersection of that tangent against, and then let's look at the intersection of this also here, okay, over here, and the values given, okay. When you plot your graph, you must write out your table, and you'll find that once you produce a table and plot it against x against y, it will come out right every time. Okay, let me just go back a little bit, find out. Okay. Okay, thank you, good. Okay, I hope you found this useful, okay, and I will continue with the other pieces that I have put together as well. But remember that you need to produce the work for yourselves. You need to plot your graph. Use graph paper at all times if you need to. So you can get familiarized with the calculation and the measurements you're going to be using in regards to your graphical representation. Okay? If you can do it on Excel, so much the better, because Excel produces some brilliant graphs. Okay? I've seen this as well when I was working at Dudley College. One of my colleagues was very good at producing the graphs on Excel. But I know it takes time. Okay. But anyway, have a good day. I hope you found this useful. Bye-bye for now. Thank you.